Hi everyone, so I'm going to go over the dilations and similarity review. So we have this first one talking about CD being the image of AB, which is important to know that CD is where you ended. After a dilation centered at P, which ratio is equal to the scale factor? You always want to remember scale factor is image over pre-image. Get a black pen maybe would be better on this paper. So image over pre-image. So what I'm going to do is CD is slanted, AB is slanted, so I would rather count vertically or horizontally. So from the center, I'm going to just draw kind of like a slope and go to both A and C, because they're the ones that are corresponding. And I'm going to count those values. So like 1, 2, 3 would be my vertical distance. I could also count my horizontal distance as 1. My horizontal distance here is 4. And my horizontal distance here is 12. To get your scale factor, image over pre-image, so CD, this was an enlargement, that means. So I'm just going to do 12 divided by 3, or I'm going to do 4 divided by 1. Either way you do it, you end up with the number. Now, in this case, they're looking for the letters of what it would be. So that's going to be image over pre-image. So I would first look for CD over AB. I don't see that anywhere. So now I'm going to look at the other options. So like PC, I don't see that anywhere, would be to PA. And then PD is to PB. And there it is right there. So it's always the center to the image, the center to the pre-image is how you would do something like that. To do it numerically, you simply divide. 4 would have been your final answer for your scale factor numerically. What's another ratio that's equal to the scale factor of the dilation? So I already said this one, CD over AB, again, image over pre-image. If AB is the image of CD after a dilation, so now they're changing it. This is the image, this is the pre-image. Okay. What is now the scale factor? So again, now it would be AB over CD, which I don't see. So now I'm going to look for basically all of these flipped. So PB over PD, because they're making it the image over the pre-image. And then same thing here, I'm going to look for that flipped. So AB over CD. What you want to remember is scale factor is always image over pre-image. Next question, we have a scale drawing of triangle DEF about center O. So it's telling us our center of dilation is right here. I'm noticing my prime is here, my not prime is there. So image, pre-image, this is a reduction. So it makes sense that my scale factor is a fraction less than 1. E to D is 20. We'll label that over there. E prime F prime is 21. And we got a few other things that I'll do after in a second. So pre-image to image, we're just going to multiply by this 3/4. So 3/4 of 20 is 15. And you would just do that through multiplication, 20 times 3 over 4. The other way, when you're going from the image, so from the prime to the pre-image, you do the opposite. So instead of multiplying by 3 over 4, you're going to divide by 3 over 4. Okay? So 21 divided by 3 over 4, which is actually multiplication. So, of course, I don't have my calculator handy. I gave it away. Pausing, sorry. So 21 divided by 3/4 would be the same as multiplying by the reciprocal for the record. But if I just type it in as is, so 21 divided by 3/4, I get 28. Okay, so I have 15, I have 28. Perimeter of the pre-image, triangle DEF, what is the perimeter? Perimeter works the same way as sides do. So you multiply by 3/4. So 68 times 3/4 is 51. Okay. If that said area, just as a friendly reminder, area you would have done times 3/4 squared. We did do that during that unit, just as a quick reminder. And if measure of angle E, so this angle here is 45, what's E prime? Well, it's also 45 degrees, because another big thing to remember by dilation is that it keeps angles the same. It preserves angle measure. Now we're looking at this picture. We have AE parallel to CB. So I have similarity because of angle, angle with the corresponding angles. AC is 4. It does not want to stay focused for you. I'm sorry, okay. LA is 2. AE is 3. The second I go to the bottom, I'm no longer thinking it's a nice, easy proportion. I said during this unit, be careful of the bottom. When that happens, you're dealing with the little triangle and the big triangle. So we're now dealing with 2 and 3. CB is X, so this is X. And then what you need to remember is that this is 6. So if you were thinking 2 is to 3 is 4 is to X, not when it's this part. If the 3 and X were over here, that would be fine. So this is 2 over 3 equals 6 over X. You are going to cross multiply to solve. And you get 9 equals X. So moving on from there, again, always double check that you have CB9. That's what I had labeled, so I'm good to go. All right. Again, we're given the parallel lines. KG is 6, so it's that bottom part again, because if you think of it like this is the top of the triangle. KG is 6, AY is 4, YT is 6, and the perimeter of triangle KGT is 30. Okay, so find GY, so this is my first X, and find KT, which is that entire length. So I'm going to just start with the first piece first and see if that comes into play at all. So I'll do 6 is to 4, so I'm doing 6 is to 4, and then I'm going to call this whole thing 6 plus X, as 6 plus X is to 6. When I cross multiply, I make sure I distribute that 4. Then I subtract 24 on both sides. And I divide by 4. I end up with X equals 3. So again, I subtracted 24, I got 12. I divided by 4 and I got 3. So X is 3. Be careful here because X is 3, which is this part. Double checking. Okay, so GY is my first answer. That equals 3. Excellent. So I now know that this whole distance is 9. KT is this whole length over here on this side. So now I'm going to go back to this. KGT. KGT. I know that 6 plus 9 plus some other number, I'll call it Y, equals 30. So really this is just now a subtraction problem. So we have 15 plus Y equals 30, so that must be 15 when you subtract. So KT equals 15. So if you ever get a piece of information like that and you're kind of thinking you should do something else, go through what you think you should do and then at the end go back and say, okay, how is that connected? The triangles below are shown are similar. Use what you know about similar triangles to find the missing side lengths of X and Y. So I'm going to start with Y. Y is that proportion where you can just do 4 is to 2 as Y is to 4. Because the parallel lines are right here and right here. You can go across like that. So that one I would just set up as is. I would get 16 equals 2Y. So Y is 8. To solve for X, I need to be careful of the bottom. So I'm going to go 4 is to X, and now here's the part that you have to remember. It's as 6 is to 7.5. 6 times X is 6X. 4 times 7.5 is 30. Divide by 6, and you get X equals 5. So we have 8 and 5 as our answers there. Okay. If the triangles are similar, over here, okay, answer the following as true as false or false. So is angle E equal to angle O? Absolutely. We know that similar triangles keep corresponding angles equal. B and G, be careful with this. This one is false. You can look at it here. B and D are the same. Or you can look at it here and see that they are the corresponding parts. So this one is true, but B was false. BE, so BE is to EN. So I went left to bottom. So I need to be going DO to OG, which I am, so that's true. Here, BE to DO, so I went left side to left side, is going EN, bottom side to OG, bottom side. Yep, I went the same, so that's true as well. I'm just going to change colors here. So BN is the well, not the hypotenuse, but that longest side. It's not a right triangle, so I can't call it that. So longest side to longest side, you see how they are corresponding. And then OG is to EN. Okay, be careful with this. It looks like that one was true, but I went BN to DG. So I went left to right. But then notice I went OG to EN. I went that way. So this one is false because it actually goes the opposite way that it should, which is tricky. Triangle BNE is similar to triangle DGO. That's true. Again, it's just talking about corresponding letters there. Triangle ENB, OGD, nope, false. You gotta go in the right order. NBE, so I should go GDO, which I did, so that's true. So that's all just a bunch of paying attention to the order of the letters or the picture for corresponding pieces. Okay, moving on to a few more examples. Are they similar? Anytime I ask, are they similar, you want to be thinking of angle, angle. Okay. You want to prove to me that it has two pairs of congruent angles. Right now I see one pair. And now I need to figure out if this is 31 or if this is 44. So I'm going to add 105 and 31 to get 136. I'll subtract that from 180. If that is 44, it is. This is a yes because of angle, angle. The 44 and the 44 and the 105 and the 105 match. Over here, same thing. I see angle, angle. I need to solve for this missing angle to see if it matches 33. So 110 and 38 make 148. When I subtract 180 from 148, I get 32. So this is a no, because 32 and 33 are not matching. Okay. Following triangles are not drawn to scale. If BD is an angle bisector, find the value of X. Angle bisector has a similar relationship. If this is the angle bisector here, it's this piece and this piece. They are proportional to these two pieces on the outside. Okay, so your proportion can look a multitude of different ways, but we could do X is to 8, so X is to 8 as 12.5 is to 10. And then you would, of course, cross multiply. You get 10x equals 12.5 times 8 is 100. So X equals 10. Here it's going to be that same thing. Here's the bisector. So it's x.5 is to x, or excuse me, x plus 5 is to x, as 18 is to 12. That's just another relationship that exists with similarity. Distribute that 12. Don't forget that part. Subtract and divide. Okay. Last one are parallel lines. Remember, parallel lines cut things proportionally. So this is 12 is to x as 15 is to 12.5. 12 is to x as 15 is to 12.5. For sake of time, I'm just going to go through these proportions. You know to cross multiply and solve. Over here, I would do 5 is to 4 as x minus 5 is to 8. Remember, if you have a different one as me, as long as your 8 and 5 would be multiplied and your 4 and your x minus 5 would be multiplied, you have the same thing as me. They're always 4 correct proportions. Here you need to be careful. 7 does not correspond to either of these two. It corresponds to this whole thing. So what I'm going to do is do 7 minus 5 and get 2. Now that I have the 2 there, I can do 5 is to 2. So 5 is to 2 as 2x plus 2 is to 4. Okay. Last one is similar, but I'm going to do the addition over here. 16 plus 8 is 24. So I'll do 28 with the 5x plus 2, and then 16 because it corresponds with the 24. So that would look like this at the end of it. Cross multiply, solve, don't forget to distribute. Okay. On to the back, we're using a compass and a straight edge, so I am just grabbing that really quick. Looks like I gave up my straight edge. Oh no, okay, I just had it hidden. Okay, we're drawing a scale drawing of the triangle with a scale factor of 2, and we want them to overlap at angle A. So that means A is my center of dilation. So I'm going to start at A. We always dilate linearly, so I go longer than I need from A through C and from A through B. Okay, what you have to remember is that this distance counts as a dilation of 1. Oh, that's not on it exactly. Okay, so that's 1. This is a dilation of 2. So that right there is C prime. A to B counts as a dilation of 1. Keep going. There is B prime. And I'm going to connect. And now here is my new triangle. That's a scale factor of 2. Okay. If I dilate a segment from O, again, I always dilate linearly. So from the center, I draw through whatever I'm dilating. I always draw a line bigger than what I think I'll need. If it's not big enough, I just make it bigger again. And now I take this and I'm going to scale factor of 3. So from O to L, remember that that counts as 1, 2, 3. O to S, adjust my compass. It looks like it's almost the same length, but just double checking. 1, 2, 3. So here's S prime. Here is L prime. Think of it like a number line. The center is 0, 1, 2, 3. If you wanted to check, that's what you should do to check. And then we have our line that we draw. Perfect. Okay, to do 4.5. So I would again dilate linearly, longer than what I need. Okay. 4.5 is in between 4 and 5. So what I'm going to do is I'm going to go, if it can fit. If not, I'll do a different option. So there's 1. This is 2, 3, 4. I'm going to go 1 more to 5. So I've gone too far. Oops, sorry. Okay, so I went 1, 2, 3, 4, 5, which I know is too far. But now what I'm going to do is bisect the distance between 4 and 5. Okay, that was really bad. Let me just fix that part here. What the heck happened there? My compass moved is what happened. Okay, trying again. If that happens to you, just take a deep breath. It happened to me too. Okay, 1 arc that way. Turning it around. And 1 arc that way. Much better. Still not great, but close enough for right now. So there to there. I grab my straight edge. And that is A prime because I went 1, 2, 3, 4, and halfway to 5. I hope you have a great day. I will see you in class.